Hey guys, so in this video we are going to introduce this idea of functions and several different ways that you can view functions. And so here you see in the box is kind of a preview and overview of chapter 8.3. We are going to look at the different ways that you can represent functions, and then we're going to kind of end in graphs, which then we will pick up in the next section on what more we can do with graphs specifically. So the first thing is we want to look at functions from several different angles so that we get a nice, good concept. So if you're drawing a sculpture that's maybe in the center of a room, you're not just going to look at it from one angle. You're going to move around the room so that you can get a nice, good, well-rounded view of whatever you're drawing. And so the first way that we can view functions is as rules. So this is what you would introduce even early on in my early childhood, folks. With rules, we looked at them back with sequences, similar concept, except now they're not going on and on into infinity. We're just looking at a set data. So I, as the teacher, would have a rule in my head. And so the students are trying to guess the rule by giving different numbers. And so the students say 1. The teacher says, okay, well, according to my rule, the answer would be 3. The student says 0. The answer the teacher would give, according to my rule, would be 0. Students say, okay, what about 4? Teacher gives an answer of 12. The student says 10. The teacher gives an answer of 30. And so we can see that whatever the student says, I then am going to multiply by 3. And that's going to be the answer. So my rule is that the student number times 3. Okay, here's the next one. Student says 2, teacher says 5. Student say 3, teacher says 7. Student says 5, teacher says 11. Students say 10, teacher says 21. And so what is the rule? This one's a little bit more difficult because it's 2 steps, but you are going to multiply 2 times the student number and then add 1. And so student says 5, you would say 2 times 5 is 10, plus 1 gives me out 11. Letter C normally trips up my students. Student says 2, teacher says 0. Students say 4, teacher says 0. Students say 7, teacher says 1. Students say 21, teacher says 1. And so this one doesn't have addition, subtraction, multiplication, or division signs. This rule is just that even numbers are going to come out as 0. And odd numbers come out as 1, and that is a rule. The second way we can look at functions is as a machine, which is kind of what I was doing in my head up here when we were making these charts. I was thinking about them as an input to an output, an input to an output. The students were giving an input, I as the teacher was giving an output, and in my brain, I knew the rule, I knew the machine. And so here's a picture. Input, it goes in whatever the function says it's supposed to do, and then it comes out a different number sometimes. So a number that goes in, we're going to call that an input. And a number that comes out, we're going to call that an output. And so write the rule using math symbols. So this machine says an x is going to go in, we're going to add 3, and then an f of x is going to come out. And so using math symbols, we're going to write the output equals the function and the input. So the output is going to be f of x because this is function f in variable x. That's what that f of x means. And that's going to equal x that goes in. Well, the machine then adds 3 to it, And so my function using math symbols is going to be f of x equals x plus 3. F of x does not mean f times x. It means that this is a function named f in variable x. That's what f of x means. It just is a way to identify a specific equation. Now we're going to use that same function and create a table of just whatever input values we want. So I'm going to just pick some inputs, 0, 1, 5, 10, and 13. So if I were to take 0 and put it into my machine, so I'm putting in 0, it's going to add 3. Well, 0 plus 3 is going to give me an output of 3. Same thing with 1. I'm going to take 1, put 1 in. It's going to add 3 and give me an output of 4. I'm going to take 5, put it in my machine, add 3, give me an output of 8. Put in 10, add 3, going to give me out 13. And then put in 13, add 3 is going to give me an output of 16. You could pick any numbers over here. I just chose those completely at random. The next way we're going to look at functions is functions as equations. And so functions as equations, definition of function is a correspondence from A to B. Sometimes you'll hear it called a mapping, which just means things are going from A to B, in which the elements of A pair with one and only one element of B. What this means in terms of math is you cannot have any repeated x values or inputs. And so I can't have any repeated x values. If I have repeated x values, it is not a function. So if an x is repeated, we would write that that thing is not a function. And so we're going to look at that kind of throughout the rest of this section. So just for now, kind of store that information. Let's use it in these arrow diagrams. So the next one is functions as arrow diagrams. And what we're going to do is we're going to use these arrow diagrams to see if these things are functions. And so does the arrow diagram represent a function? Remember, in order to represent a function, you have to have no repeated x values. This is something that I would definitely highlight, commit to memory. You will need this on the test for sure. And so arrow diagram A. 0 goes to 1/2, 1 goes to 4/3, 2 goes to 7/5, 3 goes to 10/9. We don't care what the pattern is. We don't need to write down the pattern or figure out how A maps to B. All we need to know is, does everything in the input A, is there only one x? Meaning, is there any A that has two arrows coming off of it? Well, no. So this one is a function. Versus letter D, where I've got two arrows coming off of the number 1. So that means this x value is going to two different places. It's being repeated. So this one is not a function. Make a big note that it does not matter that the y value have multiple things coming from it. All that matters is there is a repeated x value. So looking at letter B, is there any x value that's being repeated? No, because every x value has only one arrow coming off of it. So this is a function. And then the next one, does every input value or every X value have only one arrow? Yeah. Now, some people have a concern because B doesn't have any arrows. That's okay. It can have no arrows. It just cannot have more than one. So that is a function. And so the only one that was not a function is letter D. Another example of a function that people sometimes get mixed up by on homework is something like this. X is going down here to 1. Y is going here. And then we have something that's going to 2 places. Now, all I care about is this input side, the left-hand side. It does not matter that 2 arrows are going to a Y. All that matters is these points in the inputs only have 1 arrow coming out of them. So that actually would be a function. So we have functions, and then more specifically, a more special function is a one-to-one function where every X maps exactly to 1 Y and every Y maps exactly to 1 X. So there are no leftovers in any category, and so which arrow diagram represents a one-to-one? It would be arrow diagram A. It's not arrow diagram B because I've got this extra point D in the output. It wouldn't be C because I've got that extra point B. And it wouldn't be D because this thing has 2 mapping from it, and then this thing has 3 mapping from it. And so the only one that is one-to-one is A.